it's time to introduce Amy. I see you there. I'm going to give a little speechy thing here. Amy Egerter is manager with Rocky Mountain Institute's building practices, where she leads RMI's Realize efforts in California. She's going to present on that. Amy and her team are working with a broad group of stakeholders, including architects, engineers, and policy advocates, to create an industrialized zero-carbon retrofit program in California. Get it going. This effort is developing several key technologies: prefabricated envelope panels, all-electric heating, ventilation, and air conditioning systems, and enabling financing mechanisms. Prior to joining Rocky Mountain Institute in 2016, Amy worked at Atelier 10, a sustainable design consulting firm, providing sustainable design consulting, energy and daylight modeling and analysis, and benchmarking services. Amy earned her Bachelor's of Science in Civil and Environmental Engineering, with a focus in architectural design, and a Master's of Science in Sustainable Design and Construction at Stanford. Amy, welcome. Thank you so much. I'm going to stop my share.
Great. Thank you so much for that intro. I'm going to share my presentation now, and just give me a moment while I make sure I'm presenting the right screen.
Absolutely. I'm going to go over to the chat. Anyone who needs questions, comments, etc., I'm here for you. I'll help out while Amy's doing her presentation.
Awesome. Thank you, Sean. Okay, so as Sean outlined in his intro, I'm going to be presenting today on Realize California, which is an initiative within Rocky Mountain Institute. And Rocky Mountain Institute specializes in decarbonization of all the major carbon emitting sectors of the economy. So this is focused on building retrofits. So some of you might know about Energiesprong. They started a retrofit program in the Netherlands, and we have an Energy Commission grant to figure out how to adapt that model to California and if it'll work. So Realize California is really about catalyzing an equitable zero carbon building revolution. We're accelerating building decarbonization through affordable and streamlined solutions. That is our mission, and our theory of change is really thinking about the technologies, financing, and how that could lead to scalable solutions. Today, I'll be talking to you mostly about the technologies that we're developing, because that's kind of step one in what we need to develop, and taking a look at kind of what they developed in the Netherlands and how it needs to be different for the California market. Before I continue, I just want to give a shout out to all of our awesome partners, people that we're working with, either on our larger CEC grant or two of our kind of sub grants. So shout out to all these folks. Couldn't do it without you. So I'll just start off with kind of an overview of Realize's model. It's basically trying to think through what the cell phone industry did for retrofits. So basically imagine, going to buy a cell phone back in the day and having to, decide which receiver site you wanted, what communication protocol you wanted, which base station you wanted to route through, all this stuff that's totally out of your field of expertise. And then on top of that, having to find financing for, your $1,200 phone or however much they are these days. So what we're trying to do is so the cell phone industry basically decided to package all that up. You go to the store, you choose package A, B, C, and it comes with, your payment plan over 5 years. And we're trying to do the same thing for retrofits to really take the brain drain out of it, and hopefully that'll lead to greater adoption and more building decarbonization. The technologies that Energiesprong developed kind of are summarized in this little graphic here. First was the insulated facade panel. So it's basically like a fully blown wall that you would hang on top of the existing building, seal it up. It has high performance windows, high performance doors, gets it to about passive house levels of performance. So that gets hung outside the building. There's also roof panels that come integrated with solar PV infrastructure, and then you can just put the panels right on top of them. And then they also developed an integrated heating and cooling air conditioning, or heating, cooling, and ventilation system. Sorry, that's redundant on the slide. And so what they did is they just kind of hooked up these pods to the houses and were able to electrify the buildings quite quickly. They also used all electric appliances, so people will get kind of a new kitchen as well. And so when we talked to people in the Netherlands, they cited, improved living conditions. They don't have to spend as much on energy. And then Energiesprong overall cites new construction jobs that were created as well. So what we're trying to look at is all these technologies, how do they need to change for California? How is our building stock different, and how can we make this work for us? So the first thing I'm going to talk about some of our research from our overarching Energy Commission grant. The very first thing we did when we kicked off this grant was trying to figure out what types of buildings really exist in California and how can we design a retrofit package to meet the needs of those specific, most commonly occurring housing types. And so we identified 3 major building types, looking at data from REX, census data, data from LIWIP and BayREN databases, and just tried to figure out what's here. And so the 3 prototypes, which constitute like maybe 70% of the roughly 3 million multifamily units in California, are this townhouse prototype, which is kind of looks like a single family home, but is slightly larger and divided up in a different way. A garden style apartment, which is 1 to 2 stories, looks more like a traditional apartment building, but still has exterior circulation, staircases and all that. And then the third most common type was a loaded corridor building, which is, the corridor is interior and closed off and is either conditioned or unconditioned. And these buildings are typically a little bit taller. So right now, most of our demonstration sites fall into the townhouse or garden style, but we are eventually developing packages for the loaded corridor building too. Getting into the system types that we're likely to see, and I think that we are definitely seeing in our demonstration sites, are, in the townhouse and garden style, they're pretty much the same. Natural gas gravity wall furnace, central air force gas furnace, package units on the roof. You can see on this one, there's the package unit. And then either no cooling or an in-unit cooling system. And then in the garden style, you see a little bit more central system design. And then in the loaded corridor, you see more of the central system designs. But yeah, mostly using natural gas in these buildings. In Southern California, there's a little bit more electric resistance we saw. And so basically we took the results of that typology study and we went out and we tried to find buildings that we could use as demonstration sites. We have to demonstrate on 300,000 square feet of multifamily buildings in disadvantaged communities in California. So this is the map of where the disadvantaged communities are in California. There are a couple additional criteria for us since we're partnering with AEA and using low-income weatherization program funds for this. The buildings had to be affordable deed restricted housing and also in a disadvantaged community. And then we were also trying to site our buildings within certain utility territories to get more incentives to finance these projects. So right now, we're still making a final decision between some of these buildings based on scope and funding that the building owners can bring. But we're looking at a site in kind of inland Los Angeles, Southern Central Valley. So I think this site is between Bakersfield and Fresno, but closer to Bakersfield. A potential site in Fresno, a potential site in San Jose, this one's in Palo Alto, and then one in East Palo Alto, and one in San Jose, and then one up in Marysville, California. And these are what the buildings look like. They look pretty similar to kind of what we identified in the typology study. A good mix of flat roof versus vented attic type of buildings. This one is actually loaded corridor building, so that would be an interesting demonstration site too. Let's see. So getting into now that we have our demonstration sites and we know what kind of buildings we're going to demonstrate on, how do we actually design some of these technologies? What are the design criteria we need to meet for this specific building type? I should also note that most buildings in California in these typologies are stick frame, so wood structure, whereas in the Netherlands, they're mostly masonry. So, okay, all that in mind, we set out to think about, okay, what does the envelope package look like? How could we design an envelope panel? So we were trying to figure out what levels of insulation and performance we needed to target for the major climate zones in California. So we had a preliminary set of specifications from the PIAS guidelines, FIAS models everything in WFI, so we had FIAS design our packages for us based on what would meet their targets, and then we translated those into Energy Plus and kind of like did some pushing and pulling on the targets, the performance targets, to see if we were still meeting the FIAS performance targets translated into Energy Plus. Then we kind of looked at, we had those preliminary guidelines on what the R values and U values should be, and we tried to see what was available in the market. And then we finally were working with RDH to figure out what the structural capacity for buildings in this typology, what that structural capacity is, because that could be a major limiting factor in terms of how much R value we can put into a panel and what a potential panel would look like. And so those are kind of the 3 steps that we followed to define the envelope package. It turns out that the structural implications are actually pretty big, the restrictions that we were bumping up against. So this is a big decision tree that RDH made for us, and to figure out, you know, if you have a building, what you can actually do with it in terms of panelizing the exterior. Big takeaways are that for this building prototype, the low-rise stick frame building, anything beyond an additional 4 pounds per square foot in a retrofit panel is going to trigger a structural improvement, either a full seismic retrofit or just the addition of a new structural footing to support the panel. This is pretty different. 4 pounds per square foot is like a half or a third of what the weight of the panels are in the Netherlands. Also, the R values we're seeing were significantly lower from what they installed in the Netherlands. So coming out of all that, we decided to take the research route of targeting a non-structural panel, unless a seismic retrofit is needed in the building, just in general, before we even get to it. There are other research teams in Oregon. OSU and U of O are partnered on a team to research the development of seismic retrofit panels. So we kind of saw our niche as developing these non-structural panels that would be needed for buildings that don't need a structural improvement. So coming out of all of those findings, we decided to, so the energy modeling and then this understanding of the structural criteria, we came up with this decision tree. So say you're a building owner and you have a low-rise building, that's something that Realize covers right now. Otherwise, we haven't developed guidelines yet. And if the building is not in need of a seismic retrofit, and it does or doesn't have existing roof or wall insulation, you would get a different retrofit package specifically for your envelope. So if you already have existing roof or wall insulation, for the most part, Title 24 did a pretty good job of insulating buildings, and the kind of incremental improvement for the cost of a retrofit panel we didn't see is really panning out. So there would be kind of this roof only option. So you'd get a roof panel and then triple pane windows. And that's kind of, maybe your building was built in, you know, the 2000s or the late 90s or something like that, and it really doesn't make financial sense to re-insulate that building. There'd also be air sealing as part of this, and we're still trying to figure out a good way to do that, a standardized way to do that. Retrofit option B is the approach that we're kind of taking in our research, which is developing this non-structural panel. We're seeing that we can get up to R16 in that panel without getting over that 4 pounds per square foot limit. And then options C and D are if you do need a structural retrofit or seismic retrofit, and then you can get your panels up to, you know, R30, R40, or sorry, R36, R20, R30. So that's kind of, these are the major retrofit packages that we identified. For one of our demonstration sites, we're going to be using retrofit option B, so these non-structural panels. And just to summarize the difference between what we're doing, how this non-structural panel differs from what they did in the Netherlands, like you can see how robust this panel is. It's, you know, that's almost maybe like a foot thick or something, and it's 8 to 12 pounds per square foot, fully structural. This wall could be the wall for a newly constructed building too. It comes with the windows pre-integrated and doors as well. Whereas what we're doing is we're just trying to get, we need insulation on these buildings as quickly and as lightweight as possible. So our design criteria, I think we're going to be somewhere between 2 and 4 pounds per square foot. It's non-structural, so this is mostly just like a supporting mechanism for your insulation, right, that you can attach to the building. Windows and doors aren't integrated, but we are designing rough opening connections that are going to be prefabbed and hopefully shorten the amount of time to installing the window. So anyway, that's just kind of the differences of what we need, and that's mostly due to the structural concerns that we have in California. Our demonstration site for the panels is in Corona, California, which is in next to Riverside. These buildings were built in 1966. They're 2 stories, 4 units per building. They have little patios and, you know, our stick frame, basically exactly our typology. And this is kind of the design. We're going through the design process right now for that lightweight non-structural panel. And this is kind of our process that we'll go through of, you know, these are the existing buildings. There's lots of stuff on them, you know, little porticos, dormers, soffits, whatnot. And we would demo all that, make these buildings as simple as possible. And then we would panelize over that, put in new windows and panels. And then we're investigating a roof panel application for the flat roof. It's a little bit complicated because a lot of insulated metal panels, which meet our weight criteria, also require pitch in your roof. And these buildings don't really have a pitch, so we're still figuring that out. And then once all that's done, kind of making these buildings look pretty again and not just like boxes. So, you know, rebuilding some of the shading, landscaping, and then potentially PV on the roof. So that's the envelope side. I'll go briefly through kind of what we're doing on the mechanical system side. We're still aiming for that all-in-one system that the Netherlands really pioneered. And so all of our design criteria are just like, you know, it's all electric, improves indoor air quality, is maintainable, small footprint, etc. And it can provide ventilation, air, cooling, heating, and domestic hot water with controls. Differences between California and the Netherlands. In the Netherlands, they don't have to deal with existing ductwork. They do all of their heating, they don't cool. They do all their heating through radiant panels. So really they just had this air to water heat pump and they hooked it up to the existing plumbing and they were kind of good to go. And then they installed additional ductwork in the cavity between the existing wall and the new wall. Whereas we're going to have to figure out, what do we do with the existing ductwork? Do we take it out? Do we work with it? Sometimes there's mold, kind of what's our approach there? Also, we heat and cool. They didn't do that in the Netherlands. So that's really, I mean, that's why we heat and cool with air. So that's just another difference. It kind of relates to the first one. Our loads are sometimes bigger than what they have. So AEA did a comparison of a few European all-in-one systems and tried to compare those to the loads that we were seeing in our demonstration sites. And we found a few that they could meet our capacity needs, but a few of them were just a little bit too small. And that could be just because in Europe, maybe they're smaller apartments or the level of insulation and construction is just maybe a little bit higher than what we're seeing here. And then also there's just not as much of a niche market for all-in-one systems here. There aren't any available systems that we know of that can provide all of those functions in California or the US, and there are about 5 or 6 that we identified in Europe. So it's still a niche market in Europe, but it's even more niche here. But this is the one system that we're kind of investigating further and figuring out if we can install it in one of our buildings, the same building that's getting the potentially, well, we're still figuring out where we would install this, but this is a system that's manufactured in Germany, and it pretty much, you know, you can see the domestic water, the controls. I think they have an ERV somewhere in here, and then they have an air to water heat pump. And there are some modifications that we're going to be proposing to the manufacturer through another one of our CEC grants. The biggest one, I think, would be getting them to swap the refrigerant so that we can have a low GWP refrigerant all-in-one system, which is kind of the dream. And then just making sure we can use the economizer, because we can do that a lot in California. And then also potentially some more tie-ins with controls using watt time, like emissions response data and all that kind of stuff. So this is still a little bit nascent, but just thought I'd share what we're working on there. And then we were just trying to figure out how we could install this in one of our demonstration sites, just as a hypothetical. The blue lines are existing ductwork, and then we would need to install return air ductwork and exhaust ductwork, so for the ERV function of the pod. And then you can see here's where the pod would sit outside, and then this is the size of the enclosure that the pod would need. And so we'd have one per unit, and these are 2-story units. So yeah, it's kind of a more complex problem to solve, again, similar to the panel side, than what happened in the Netherlands, just because of this ductwork issue.
Hey, Amy,
yeah.
can I interject a question? People are wondering who is making this equipment in Germany. Do you know?
Yes, this manufacturer is Systemair, and we're still trying to we're still finalizing whether or not we'd use this system or not. But yeah, the 2 systems that we found that meet the load criteria in California were manufactured by Systemair and Clevet. So yeah, those are the 2 kind of highest potential ones that we found. And I'm just talking about this one for the sake of, I think we just have the most information for the drawings and whatnot. So that is the progress on the mechanical side. Next steps for us, we're going to be releasing an emerging technologies report sometime in the middle of this year that will go into much more detail about the stuff that I talked to you about today. Our demonstration sites are starting construction the middle of this year, and will run into the middle of next year. And then yeah, I think once we get the technologies and the costs kind of nailed down, we'll start digging more into the policies and financing mechanisms that we can use to really get these things off the ground, with recommendations to all the relevant regulatory bodies. So I'll stop there and say thank you, and shout out to IBG. If she can lift weights at 90, we can make decarbonization retrofits happen. So yeah, thanks everyone.
Absolutely. Thank you so much, Amy. So we have some questions for you that is rolling through.
Awesome.
So a question was like, about how much energy do you think that you're going to be able to save? In a before and after kind of way. It's a whole big package of questions, but.
Yeah, so we kept the HVAC parameters the same in all of our envelope packages. So we had the 4 envelope packages, and I think for the most robust envelope package, we got to like 80–85% energy savings. Like it was pretty significant. And I think we're about like 50 or 60 or something for the lightweight panel option, which is a little bit less insulation. I think, oh, sorry, go ahead.
No, I was impressed. Like R16 is a lot to squeeze into a lightweight panel.
Yeah. We thought we would only get to R8, but RDH did some modeling for us this past week, and looks like we're going to be able to get more, which is awesome.
Congratulations. A question around the MERV rating. Do you know what you're going for air cleaning on that HVAC filter?
Ooh, I do not, but I can get back to you on that.
No worries. I assume it's going to be like MERV 13 or better, because that's what required.
It definitely is going to meet code. I don't know if we're going above that, though, is the thing. Yeah.
I mean, that gets almost all of it out at MERV 13. That's good. Let's see. There's a question if you were considering mini splits versus a ducted system. What's your thought there in that mechanical?
Yeah, I think we do have a non-ductless option that we're considering. We just went through a bunch of mechanical options. So I just shared this one, but we are considering kind of a more traditional rooftop version and then a ductless version. So yeah.
Cool. It was Martin Volker is saying that he sees roofs that look like hedgehogs with tons of penetrations. Yeah. How much of a problem is it to centralize or eliminate venting?
Yeah, so Integral Group is looking at that for us today. When we had this call earlier this week to go through the mechanical options, for this system area, you you can get rid of, well, there's no rooftop equipment, and then I think you can get rid of most of the rooftop penetrations except for the plumbing vents. And so, I mean, it's a big deal for a roof panel too, right? Because you would want to have a continuous panel as much as possible. So we're trying to figure out how much we could bend. Like, we wouldn't want to go inside the building to move where the plumbing vents go. So it's more like, could you bend the plumbing vent at the roof and like centralize it somehow? And I think integral, like, we just need to look into what's actually possible. Because yeah, the rooftop of the building I showed you is definitely peppered in no systematic way with penetrations. Yeah.
A question here was sort of the life cycle. Brendan asked, really interesting project. I've wondered about Energiesprong. How do the life cycle economies and environmental impacts compare to just doing mechanical system electrification with high efficiency heat pumps? So how much benefit to reduce peak and total loads through the envelope retrofits compared to just electrification?
Yeah, so the inclusion of the envelope panel and the reduction in like air infiltration was pretty key to be able to use one of these all-in-one systems. The all-in-one systems are quite large and heavy to begin with, and I think making sure that the loads are lower is going to be key to using them, and also just reducing the amount of mechanical systems that you have to buy. We haven't done like a cost trade-off for mechanical versus envelope investments, just because we haven't gotten full costs for our panel design yet. I could see in some climates, like maybe the Bay Area or like LA area, coastal LA area, it really not making a ton of sense to fully panelize everything. But what concerns me is the air sealing. Like, as we've all learned from living through multiple fire seasons, it's just not great to like be in a smoky house for 3 months out of the year. So I think a big thing for us is just how do we seal up the buildings and make sure that the indoor air quality is improved if we don't do a panel. And one of the benefits of the panel is doing that air sealing.
I've seen, at least in Ohio, that like air sealing and a little bit more insulation can reduce the size of the HVAC system by half.
Yeah.
Only like a 50% drop in sizing. So
yeah.
It's certainly climate dependent, but can be a really big deal.
Right.
Amruta wanted to know if you were expecting a drop in the efficiency of this new water heating system.
Ooh, that I don't know. I'm leading more of the panel stuff, but I can send a lot of these mechanical questions to our team. AEA is leading the pod development. I haven't heard anything about it, but I can ask.
Okay, and then Alice asked, did you or could you analyze how much indoor air quality and ventilation and filtration is improved compared to standard or existing? So what might we think is the improvement? With a focus on COVID and PM 2.5, that might be good to know as a quantifiable co-benefit of the systems.
Yeah, well, I think the main thing is that we're actually putting in ventilation systems in a lot of these buildings that don't have them already. So that's a big step up and kind of a key mandate that we've taken into our program. So like the building that I was showing you, they just have exhaust in the kitchen and the bathroom. And then all other ventilation is just like whatever comes through the walls. And I think that's pretty typical. So yeah, we are going to try and monitor some of the air quality before and after the retrofit, but I think just having that ventilation system in there will help. So.
Okay, well, we are at the half hour. So yay, Amy! Woo-hoo!
Thank you guys.
Fantastic.